Hello everyone, welcome to my class. In today's class I'm going to cover binomial theorem. So let me start the class right away. First, let me give you an overview. A polynomial with two terms is called a binomial. For a binomial, a plus b, here two terms are a and b, we know the perfect square formula. A plus b is square equals to a square plus 2 times ab plus b square. Similarly, a minus b square equals to a square minus 2ab plus b square. Notice that the expression of a plus b square or a minus b square begins with a square and ends with b square. In these sections, we study how to find a plus b raised to the power n without multiplying the binomial by itself n times. Next, definition of binomial coefficient. For any natural numbers n and r with n greater than or equals to r, the expression here n r, we read this as n choose r at a time, is called the binomial coefficient and is evaluated as follows. N choose r equals to, this is the fractions here, in the numerator n times n minus 1 times n minus 2 times n minus 3 times dot 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 n minus r minus 1 over r factorial, or n choose r equals to n factorial over r factorial times n minus r factorial. So this is the value of this binomial coefficients n choose r. Let's do a quick example 1. Compute the binomial coefficient 7 choose 4 at a time. So then by this formula here in the solutions, 7 choose 4 equals to, here n is 7, r is 4, so 7 choose 4 equals to, by this formula, 7 factorial over 4 factorial times 7 minus 4 factorial. In the next step, in the numerator 7 factorial as it is, and in the denominator 4 factorial as it is, and 7 minus 4 is 3 factorial. And in the next step, so 7 factorial, we can rewrite 7 factorial as 7 times 6 times 5 times 4 factorial. We stop at 4 factorial because we have 4 factorial in the denominator, so we can cancel the 4 factorial in numerator and denominator. In the denominator, we have 4 factorial times 3 factorial. We cancel the 4 factorial in numerator and denominator. Then in the next step, we have 7 times 6 times 5 over 3 factorial. Since 3 factorial is 3 times 2 times 1, which is 6, 6 and 6 cancel in numerator and denominator, so we have only numerator 7 times 5, 35 left. Awesome. So the value of 7 choose r at a time equals to 35. Hence, the binomial coefficient 7 choose r equals to 35. Great. Quick remark. Some useful formula. N choose 0 turns out to be 1, n choose 1 turns out to be n choose n minus 1 turns out to be n, and n choose n turns out to be 1. And observe that n choose r equals to n choose n minus r. These relations are true. Let's move on. Let's do example 2. Example 2, compute the binomial coefficient 7 choose 3. Then solutions. 7 choose 3 equals to, let's apply the formula here. Here n is 7, r is 3. So this equals to 7 factorial over 3 factorial times 7 minus 3 factorial. This equals to 7 factorial over 3 factorial. 7 minus 3 is 4 factorial. And the next step, 7 factorial is 7 times 6 times 5 times 4 factorial. We stop at 4 factorial because we want to cancel the 4 factorial in numerator and in denominator. And denominator is here, 3 factorial times 4 factorial. And in the next step, we can cancel the 4 factorial in numerator and denominator. Then we have 7 times 6 times 5 over 3 factorial left. Since 3 factorial is 3 times 2 times 1, which equals 6, and 6 and 6 cancels, so we have only numerator 7 times 5, 35 left. So example 2 and example 1. In example 2, we compute the binomial coefficient 7 choose 3, and in example 1 we computed the binomial coefficient 7 choose 4. Both turned out to be the same value 35. So this verifies our result here. This verifies the fact given in the pink color here. N choose r equals to n choose n minus r. Awesome. Next, remark, for any integer n and r, for r between 1 and n, we have n choose r minus 1 plus n choose r, turns out to be n plus 1 choose r. Great. Now let's do example 3. Let's add the binomial coefficients 5 choose 3 plus 5 choose 4. Then by this quick remark here n is 5, r is 4. So the sum of these binomial coefficients turned out to be n plus 1 choose r. That means 5 plus 1, which is 6. So the answer is 6 choose 4. 6 choose 4, which is here. So now let's verify this result. So now let's begin the solution of example 3. So here 5 choose 3 equals to 5 factorial over 3 factorial times 5 minus 3 factorial, the plus as it is. Similarly, 5 choose 4 equals to 5 factorial over 4 factorial times 5 minus 4 factorial. Here I just apply the formula that we wrote here. Okay. In the next, now let's simplify this step here. So in the next step, copy the 5 factorial as it is, 3 factorial in the denominator as it is, subtract 5 minus 3, which is 2, so then 2 factorial. Similarly, 5 factorial as it is, 4 factorial as it is, 5 minus 4 is 1, so 1 factorial. Great. I hope this makes sense to you all. In the next step, let's add these two fractions. So let's use the idea of making the same denominator here to take the LCD out. So here, to make the same denominator, let's multiply by 4 to the first fractions and divide by 4. Similarly, to the second fractions, multiply and divide by 2 factorial at the same time. So here's 4 times 3 factorial becomes 4 factorial and 2 factorial, and the next denominator is 2 factorial, 4 factorial. So we can take the LCD as 4 factorial and 2 factorial here. Then in the numerator we have 5 factorial, we factor out 4 plus 2 factorial left here. In the next step, here's a 5 factorial in the numerator, 4 plus 2, which is 4 plus 2 factorials. By the way, 2 factorial is 2 times 1, so simply 2. That means 4 plus 2 is 6 over 4 factorial 2 factorial. And in the second last step here, 5 factorial times 6 becomes 6 factorial over same denominator as 4 factorial 2 factorial, and hence 6 factorial over 4 factorial times 2 factorial is same as the binomial coefficient 6 choose 4. I hope this makes sense to you all. Great. Awesome. So next, let's talk about the binomial theorem. The binomial theorem says the binomial a plus b raised to the power n equals to n choose 0 a raised to the power n times b raised to the power 0 plus binomial coefficients n choose 1 times a raised to the power n minus 1 times b raised to the power 1 plus binomial coefficients n choose 2 times a raised to the power n minus 2 times b raised to the power 2 plus dot dot dot, and the last one is the binomial coefficients n choose n times a raised to the power 0 times b raised to the power n. So here our binomial coefficients are n choose 0, n choose 1, n choose 2, dot dot dot, n choose n, and the terms are here a to the power n, b to the power 0. In the next term, we subtract the power for a and we raise the power of b. So here a to the power n minus 1, so 1 less than the previous power of a, and the b has power 1. We increase the power for b from first terms. Similarly, in the third term, a n minus 2 times b square. So here again we subtract the power of a by 1, we raise the power of b by 1 from the previous terms, and so on. I hope this pattern makes sense to you all. So now quick note, in the expansion of the binomial a plus b raised to the power n, there are n plus 1 terms, and the degree of each term is n. The exponents on the first term a begins with n and decreases to 0, whereas the exponents on the second term b begins with 0 and increases to n, so which you observe here. Let me go back again this binomial theorem here. So a to the power n, and then we decrease the power of a in the second term. In the third term, we decrease the power of a again by 1. Dot dot dot, we end at a to the power 0. Similarly, the power of b, which starts from 0, and then we increase the power of b by 1 in the next term, and the next term we increase by 1 again, and dot dot dot, we end these expansions in b to the power n. The kth term of expansions, the binomials a plus b raised to the power n, can be found using the formula n choose k minus 1 times a to the power n minus k minus 1 times b to the power k minus 1. Awesome. Now let's move on. Let's do example 4. Example 4, part first. Let's expand the binomial a plus b raised to the power 3. So in solutions, a plus b raised to the power 3 equals to, using the binomial theorem here, 3 choose 0, that's the first binomial coefficient, times a to the power 3 times b to the power 0. So here we started the power of a from 3 and b from 0. Now in the next terms, we are decreasing the power of a and we are increasing the power of b. The next step, the binomial coefficient is 3 choose 1 times a square times b to the power 1. So here we decrease the power of a, we increase the power of b from the previous terms. In the third terms, the binomial coefficient is 3 choose 2 times a to the power 1 times b to the power 2 plus the fourth term is 3 choose 3 times a to the power 0 times b to the power 3. I hope this makes sense to you all. In the next step, let's use the binomial coefficients formula to compute the binomial coefficients. So in the next step here, 3 choose 0 is 3 factorial over 0 factorial times 3 minus 0, which is 3 factorial, times a cubed, b to the power 0 is 1, then plus 3 choose 1 becomes 3 factorial over 1 factorial times 3 minus 2 factorial times a square times b plus 3 choose 2 becomes 3 factorial over 2 factorial times 3 minus 2, which is 1 factorial, times a times b square, and plus 3 choose 3 becomes 3 factorial over 3 factorial times 3 minus 3, which is 0, 0 factorial, times a to the 0 is 1 times b cubed. Awesome. So I hope again this makes sense to you all. And in the last step here, 3 factorial cancels, and since 0 factorial is 1, so we have the first term is a cubed, and then plus 3 factorials can be written as 3 times 2 factorials, and we can cancel the 2 factorials in numerator and denominator. So we have 3 left in numerator, and in the denominator 1 factorial, which is 1. So 3 over 1 is 3. So 3a square b. 3a square b. Plus, I'm in the third term here. Similarly, 3 factorial over 2 factorial is simply 3. By the way, 1 factorial is 1. Times ab square. So here 3ab square. And plus 0 factorial is 1. 3 factorial cancels. So only b cubed left. So we have the formula now. The binomial a plus b raised to the power 3 equals to a cubed plus 3a square b plus 3ab square plus b cubed. I hope this expansion makes sense to you all. So now let's move on. Let's do example 4 part 2. Let's expand using the binomial theorem the binomial a plus b raised to the power 4. Then this equals to, using the binomial theorem, so here the first binomial coefficient is 4 choose 0 times a raised to the power 4 times b raised to the power 0. Since b raised to the power 0 is 1, so I wrote 8 raised to the power 4, which is a4 here, plus the second binomial coefficient is 4 choose 1 times a raised to the power 3 times b raised to the power 1. So in the first term here, a has power 4. Now in the second term, a has power 3. We decrease the power for a by 1. Similarly, in the first term, b has power 0, and in the second term, b has power 1. So in the second term, for b, we increase the power by 1 from the first term. Similarly, in third term, the third binomial coefficient is 4 choose 2 times, with the same idea, a has power 2, b has power 2. So we increase the power of b, decrease the power of a. And the fourth term, the fourth binomial coefficient is 4 choose 3 times a b cubed, plus the last term is the binomial coefficient is 4 choose 4 times b raised to the power 4 times a raised to the power 0. By the way, a raised to the power 0 is 1. I hope this formula makes sense to you all. Now in the next step, let's use the binomial coefficient expansion formula. So 4 choose 0 is 4 factorial over 0 factorial times 4 factorial. A raised to the power 4 is as it is, plus 4 choose 1 is 4 factorial over 1 factorial times 3 factorial, then times a cubed b1, plus 4 choose 2 equals to 4 factorial over 2 factorial times 4 minus 2, which is 2 factorial, times a square times b square, then plus 4 choose 3 is 4 factorial over 3 factorial times 4 minus 3, which is 1 factorial, times a b cubed, plus 4 choose 4 is 4 factorial over 4 factorial times 4 minus 4, which is 0 factorial, times b4. I hope this makes sense to you all. Then in the last line, so we can simplify here. So then 4 factorial cancel, so only the first term is a raised to the power 4. And the second term here, 4 factorial can be written as 4 times 3 factorial and cancel the 3 factorial in numerator and denominator. So then we only have 4a cubed b. By the way, 1 factorial is 1. The third term, 4 factorial is 4 times 3 times 2 factorial. We can cancel the 1, 2 factorials there. So we have in numerator 4 times 3, which is 12, over only 1, 2 factorial, which is 2. Then 12 divided by 2 is 6. So we have 6 here in the third term. A square b square plus the fourth term. Here we can again write 4 factorial as 4 times 3 factorial and cancel the 3 factorial in numerator and denominator. And we know 1 factorial is 1. So we have only the coefficients 4. So then 4 times ab cubed, which is here, the fourth term. Similarly, the last term is b raised to the power 4. Since 4 factorial cancels and 0 factorial is 1. Great. So we have the solutions here now. We have the expansions of a plus b raised to the power 4 equals to a4 plus 4a cubed b plus 6a square b square plus 4ab cubed plus b raised to the power 4. Great. I hope this expansion makes sense to you all. So now one final comment here. In the first example, we expand the binomial a plus b raised to the power 3. So then there are total 3 plus 1, 4 term in the expansion. Similarly, in the second, we expand the binomial a plus b raised to the power 4. So then there are total 4 plus 1, 5 terms here. Awesome. Now let's move on. Now let's do example 5. Find the 7th term of the binomial x plus 2y raised to the power 9 without fully expanding the binomial. So solutions. So here I'm going to use this formula. Let me show you the formula here. The kth term of expansions, the binomial a plus b raised to the power n, can be found using this formula here. N choose k minus 1 times a raised to the power n minus k minus 1 times b raised to the power k minus 1. So in our questions, let me see what's our n. N is 9 and k is 7. So what I need now, I need k minus 1. So then 7 minus 1 is 6. So we are finding here 9 choose 6. So k is 7, so k minus 1 is 6. Compare the binomial x plus 2y raised to the power 9 to the binomial a plus b raised to the power n. We have a is x, b is 2y, and n is 9. Then by the formula I wrote down here, so the formula is here. So the n choose k minus 1 times a raised to the power n minus k minus 1 times b raised to the power k minus 1. This equals to n is 9, k is 7, so k minus 1 is 6. So we have the binomial coefficients 9 choose 6, and times here a is x, and the power is n minus k minus 1. N is 9, k minus 1 is 6, so 9 minus 6 is 3. So here the power is 3 for x. So x cubed times b equals to 2y, so 2y raised to the power k minus 1, k minus 1 is 6, so 6. I hope this setup makes sense to you all. Then in the next step, let's expand the binomial coefficients. Here 9 choose 6 becomes 9 factorial over 6 factorial times 9 minus 6, which is 3 factorial, then times, so here x cubed as it is, this 6 power is for both 2 and y, so 2 raised to the power 6. Here I put the constant here, and y raised to the power 6 is here. Now let's simplify the coefficients here. Let me do this, maybe this, that's better. Then in the next step here, so 9 factorial equals to 9 times 8 times 7 times 6 factorial. Let's stop at 6 factorial so that we can cancel the 6 factorial in numerator as well as in denominator, over denominator as it is, 6 factorial times 3 factorial, and in the numerator times, I copied the 2 raised to the power 6, x raised to the power 3, and y raised to the power 6 as it is. We cancel the 6 factorial here. I put the red color here. And then 3 factorials equals to 3 times 2 times 1. So 1, 3 cancel the 9 3 times. The 2 cancel the 8 4 times. So we have 3 times 4, 12 times 7, 84 left on our coefficients here on the numerator, and then the rest as it is. So 2 raised to the power 6 as it is, x cubed as it is, y raised to the power 6 as it is. In the final step, using calculator, multiply 2 6 times and then multiply that result to 84, and it turns out that the coefficient is 5376, then times x cubed y raised to the power 6. Awesome. So we found the 7th term of this binomial expansions, which is this expression here. I hope this makes sense to you all. So we finish this sections, the binomial theorem. Quick aside, I put a binomial series definitions here, which we will not cover in this class. So we finish this section at example 5. Thank you.